Thank you. Thank you for the introduction. So I'm very happy to see you here. So I will give my talk together with Sina from OGC, but Sina, unfortunately, he's not here. So I will start from the background of this work. It is a part of the pilot project, OGC pilot project called Urban Digital Twin Interoperability, which is funded by the Korean Land and Housing. Korean Land and Housing is a company who take care of the digital twin in Korea. So this project began from the middle of the last year and ended in February of this year. So the background of this pilot project, so actually the pilot project, it is setting up a digital twin framework based on OGC standard. So it is not only for GeoAI, but also some other functionality of urban digital twins, such as noise management, which is very critical in urban planning. But anyway, this work starts from the requirement of UN, where UN field mission, they are very largely affected by the road surface or road condition if there is a flooding. So it is very difficult to send a vehicle or the UN officer to the field, so they want to know the road status in real time. So they have a very strong requirement from the United Nations. So we try to set up a kind of ecosystem starting from a geo-referenced imagery data collection to the visualization. Of course, we need a GeoAI module for training and analysis. So the goal is to set up a GeoAI framework. It is not a general GeoAI framework, but specifically for road surface classification and object detection if possible. So we try to make this kind of a framework based on OGC standard. Well, the goal is to provide a GeoAI framework. First of all, the road classification, road surface classification. Of course, there are so many classification of road surface, which is defined by OpenStreetMap. But we start from 3 categories: asphalt, paved road, and unpaved road, because we have the problem of the resource, so we decide to start from this 3 categorization. And we analyze the state of the road surface and visualize it. There are many teams involved in this project. So one of the OGC, they lead the whole project, and LH and the United Nations, they got involved as a potential user. And for the contributor or developer, there are so many teams like our university or University of Southern California of the United States, and the University of Central Florida, UN University, YTech, and the University of Stuttgart and Helix, etc. So it is a quite huge team. So first of all, I'd like to show some video clip.
The system classifies road surfaces into categories such as asphalt, paved or unpaved roads. The workflow consists of 3 steps. Camera images are captured using smartphones mounted on mission vehicles. These images, along with geospatial data, are processed into OGC GeoPose and OGC TrainDML formats for AI training. The dataset is transferred to the Urban GeoAI platform, which then passes that data along to the GeoAI analysis module using OGC-API standards. The system trains a deep learning model using different ResNet architectures. When a new geo-referenced image is submitted, the trained AI model classifies the road surface type. The results are displayed in the visualization module, allowing users to analyze the classification results with additional geospatial data.
Okay, that's it. All right, so I will give a little bit more detailed information.
The system
sorry.
classifies
So that is the very first step of that framework, which is the geotagged image collection. We install a kind of smartphone dashboard camera on vehicle, so that we capture the data, not only the image, but also the location geotag information such as the GNSS data or the orientation data. Then we process it to make a so-called GeoPose data to specify the location and direction of the image. Then this data is sent to, of course, we need to label the data, and it is converted to so-called TrainDML for AI format, which is the OGC standard for GeoAI. Then, so this is for labeling. So we install the smartphone on top of the mission vehicle or any other vehicle. So this is the image, the video file that we collected from that smartphone. Then we label them such that it is on paved road or the asphalt or etc. Okay. And first of all, the first OGC standard that we used is GeoPose, which define the geographical, the position data and orientation data. So it is very simple here. So we have an identifier of the camera and type and the timestamp, and we have the position data, pose data, let alone the data, and the direction. It could be this one or all right, so then this GeoPose data is sent to OGC TrainDML data, which is a kind of metadata for the GeoAI training module. So, for example, here, that part of TrainDML, this is a JSON file. So this part is extracted from GeoPose, and it includes some other metadata for the image. So each image has that kind of metadata. Then it is sent to GeoAI module to train the model, and the data is collected from, so the requirement is given by UN GSC, which is located in the Brindisi in Italy, and UN VMC. VMC is in Colombia for verification mission. So the basic classification is based on OpenStreetMap, but we initially start from a straight classification, which is asphalt, paved, and unpaved one. Right. For the classification, we used two data. The first one is a so-called RTK, which is a very public data. And this data is collected in terms of IEEE Big Data Conference as a kind of competition program, which is very complete data. And for our case, we collected around 1,000 image data. Of course, it is geo-reference data from UN VMC. Then we applied several types of deep learning model, like ResNet 50 and the Inception, and so on and so on. So we compared them to see the result of the accuracy, and we found that the ResNet 152 is the best among that. But anyway, we may use any other method for this geoanalytics or GeoAI. This is only some example that we applied. And then the data, the result is sent to the visualization module. So the first one is on top of OpenStreetMap, where the red dot means it is asphalt, and the The yellow one is unpaved one, and the blue one is paved one. So if you click any dot on this road, then it gives more detailed information such as the image and so on. And the right one is visualization using cesium. So the functionality is almost the same. Right. So our development is totally based on open technology such as open source software. So these are the set of open source software that we have used, like Label Studio or open camera sensors, etc. And of course, we have used OGC standard like open GeoPose or open the TrainDML for Geo-AI and the open API standard. Right. And these are the list of the open source software that we have used, like CVET and the Label Studio, etc. And some of them are something that we developed. Right. One thing that I'd like to mention before ending my presentation is the extensibility. It is very extensible because our system is based on OGC standard. For example, here it is a part of TrainDML. So in this case, our classification is only for 3 categories, but if you want to include more classification, you just add more classes. Like for example, we may classify a muddy road or some other type of the road classification. And if you want to add more functionality like object detection, you just modify this TrainDML data. Then the deep learning module receives that metadata to apply their proper deep learning model. So this module is initially in the aim to make a road classification, but it could be applied to object detection of the roadside or damage analysis or even to other type of urban situational awareness. Right. So it is too short. Right. So as a summary, I just give a very brief presentation on what we have done for Geo-AI framework for road classification and detection, so which is developed as a part of OGC pilot project funded by Korean LH. And this is totally based on OGC standard for interoperability. So if you want to get more information, you may access to the OGC portal. So this is engineering report which includes every detailed information about that project. And if you have any question or suggestion, you may contact with myself or my colleague Sina from OGC. Okay, that's it.
Thank you for your presentation. We've got plenty of time for questions, so just raise your hand, I will come to you.
Whereabouts were the roads that you studied? Where were the roads? Which country or which part of the country?
So there are 2. So the first is collected from Colombia. So the officer from UN VMC, VMC is UN mission office in Colombia, Bogota, the capital of Colombia. So they collect some data around the Bogota. This is the first one. And the second one is so-called RTK, which is collected from Japan and Germany and so many countries for the IEEE big data competition program. So if you access to RTK, then you may find a bunch of the data. So this is wonderful.
What other road assets do you think we can also identify and, let's say, segment based on this approach?
Yeah, that is a good question. So the first of all, we applied it to road surface classification. But if you want, you may apply it to detect road damage. The cracked one, the vertical crack, or horizontal crack, or some other type of crack. And this is not this project, but we apply almost the same module to the Los Angeles city government to detect, how can I say, the dumped object on roadside. So I'm sorry, in the Los Angeles municipality, they have a very serious problem of dumped object.
Like
So
waste?
They
Waste
have to
object,
detect.
like something like waste?
Yeah,
Roadside waste.
yeah.
Okay.
But you have to change the TrainDML data to that application.
So I have a question about the TrainDML data. That is external data or internal data, just like EXIF? And also the TrainDML data directly reads several type of the deep learning models, or you did convert this data for the training data?
Okay, so the question is about how to make a TrainDML data. So this is an independent data, external data. So you have to make the TrainDML data from the data collected from, for example, smartphone, which include the location data and the orientation data. So first of all, this information is included in so-called GeoPose standard. Then there is a tool to convert GeoPose data to TrainDML data. It is almost fully automated. So, and then the GeoAI module, deep learning module, receive that TrainDML data to know what kind of the classes they have to classify and the metadata for each image, right? Then they apply that data to make the training deep learning module.
But sometimes we have to convert the training model labeling data for individual AI models.
Yeah.
So that is it possible to automatically convert TrainDML to each AI models?
Yeah, yeah. So once we have the label of each image, then it will be included in the TrainDML data. So this is for TrainDML.
Any other question? All right, let's thank our speaker.
Okay, thank you.